For the last few years, our primary interaction with artificial intelligence has been surprisingly uniform, typing prompts into a generic text box hosted somewhere on a public cloud server. That setup created an operational vacuum. When organizations attempt to run complex enterprise data pipelines or pilot physical robotics, those public cloud models often lack the speed, safety, and integration required to function in the real world. On August 24, 2026, a series of global announcements across telecommunications, healthcare, and state security signaled a different trajectory, indicating that AI is increasingly moving into specialized, localized roles. Instead of one massive cloud, this intelligence is taking root across three distinct environments: embedded digital workflows, physical hardware, and tightly guarded sovereign borders. To see where the technology is heading, we have to look past the foundational models themselves and focus on the specific environments where they are actually deployed. We begin on the digital frontier, where raw artificial intelligence is being injected directly into the software engines of major enterprises. We see this in software development itself. xAI recently pushed its Grok bot directly into developer IDE ecosystems, the specialized environments where programmers write software, to provide direct code generation natively as developers type. This real-time synthesis is also scaling up to monitor live global events, using the scale of the 2026 US Open as a testing ground. To handle that constant data flow, IBM built a dynamic personalization engine that tracks complex court statistics and synthesizes real-time editorial content for fans without human intervention. That same principle of dynamic data synthesis is streamlining highly technical scientific workflows, particularly in computational structural biology. The biotechnology firm Resnomics recently entered Eli Lilly's Gateway Labs accelerator, deploying AI-driven RNA editing workflows to automate complex research for oncology and degenerative disease pipelines. Across this digital frontier, AI is functioning as the invisible computational backbone running inside existing industries. Software is only half the equation. These systems are breaking out of digital screens and achieving physical embodiment in the real world. The robotics firm Beijing Galbot recently deployed their AstroTennis humanoid system, specifically to test how well an AI can handle high-speed physical perception and dynamic balance recovery. The robotic system successfully executed well over 100 consecutive, highly dynamic autonomous tennis rallies against a live human competitor. Getting a machine to move autonomously requires a constant, massive stream of zero-latency sensor telemetry. Standard cellular networks often cannot handle that volume of immediate data. To bypass this bottleneck, China Unicom and Huawei deployed a specialized 5G advanced Giga uplink network slice in Beijing, engineered exclusively to carry robotic telemetry. The race for embodied AI relies on securing specialized telecommunications hardware and upgrading physical infrastructure. As these systems gain the ability to manipulate critical corporate data and execute physical actions, they become highly valuable attack vectors. Global security consortia recently documented a sharp rise in high-severity vulnerabilities occurring across multi-agent execution stacks, especially when autonomous agents hand off tasks to one another. In response to these threats, large organizations are enforcing data residency mandates, requiring mandatory 30-day audit logs for any frontier model they plug into their systems. Anthropic partnered with Salesforce to deploy dedicated private cloud logging infrastructure, allowing corporate clients to lock down their AI data within their own isolated tenants. National governments are escalating this lockdown. France's digital agency mandated that public sector AI assistants must be hosted within strictly certified regional data centers, while European infrastructure providers are scaling up inference endpoints that guarantee zero data ever leaves the physical region. For artificial intelligence to operate at a massive scale, it must bend to the physical borders and the geopolitical sovereignty of the nations hosting it. Across the digital, physical, and sovereign frontiers, artificial intelligence is maturing into a highly specialized industrial architecture. The organizations and nations that will lead this cycle are the ones building the fastest physical networks and the safest sovereign data environments. Generic models running on public cloud servers are increasingly being bypassed in favor of these specialized, governed environments. To continue tracking the future of industrial intelligence, subscribe to AI Vanguard AI, like this video, and share your thoughts in the comments below.